Now coming to your subject, that is microprocessor, right? Now in this subject we will discuss in detail with a particular microprocessor, that is basic version of microprocessor, and we will see difference between your microprocessor and microcontroller, and we will see instruction set of a microprocessor, and we will see instruction set, that is it operates, and that means it performs arithmetic and logical operations. Microprocessor will perform arithmetic and logical operations. Now what are the instructions under arithmetic operation? Now what are the instructions under logical operation? We will see that later, right? Now let me briefly explain now what is meant by the microprocessor. Now let me give an introduction to microprocessor. Now what it will do, what are the internal parts of microprocessor, now where the microprocessor is present, now where we can use microprocessor. Now let us see all these details, right? Now the first topic under your microprocessor subject is introduction to microprocessor. Let me give its introduction. Now if you are perfect at your basics, then you can easily understand any microprocessor. If you are perfect at your basics of a microprocessor, after that introduction we will see the architecture of a particular microprocessor. If you are perfect at these two topics, then you can easily understand any microprocessor, right? Then you can easily understand any microprocessor. Now let me give its introduction first, right? Now what is mean by microprocessor? The micro, which indicates small, right? Now processor, which process something, right? Now the microprocessor, which is nothing but the central unit of the computer. Now this performs ALU operation. This is the central unit. Microprocessor is the central unit of a PC, nothing but your computer. Now this, what it will do, it will perform ALU operations, right? Microprocessor, which is very small in size, the name itself indicates micro, which is very small in size and which is the central part of the computer system. Now which will do arithmetic and logical operation, right? You know arithmetic operation, that is addition, subtraction, multiplication and division. Now you know logical operation, and operation, or operation, not, and, nor, XOR, XNOR, right? These operations are performed by your microprocessor, right? Now microprocessor, which is very small in size, which is nothing but the central unit of a computer system. Now this will perform arithmetic and logical operation, right? Now this is what is meant by the microprocessor. Now where we can use microprocessor? The name itself indicates processing, right? Processing, that means you are programming something, right? Micro is nothing but which is very small in size. Now that particular electronic device, and this is an electronic device which is very small in size, will perform some programming, right? Will perform some programming, right? Now that is what is meant by the microprocessor. Now what the programming includes arithmetic and logical operation, right? Now the microprocessor is used where we require programming. Wherever we require programming, at that particular situation you can use microprocessor. Now let me give an example. Say you have a remote, TV remote, right? Now if I press 1 under your remote, then channel 1 will be displayed. If I press 2, channel 2 will be displayed, right? Now that particular program is given to the microprocessor, and that microprocessor is embedded in your remote. Remote contains a microprocessor, and that microprocessor we are giving a program, right? If I press 1, channel 1 should be displayed. If I press 2, channel 2 should be displayed. This particular program is given to your processor. Now that processor will operate according to that program given to you, right? Now the remote, TV remote, basic processor it contains. Now if you see traffic lights, right? Now what are the different lights you will observe? Red light, yellow light and green light, right? Now at a particular time, one light will be displayed. Now after that particular time, another light will be displayed, right? Now there also we are using microprocessor. Under traffic light system also we are using microprocessor, right? We will give a program to that microprocessor to this duration, that means either 2 minutes or 5 minutes depending on the user, to this particular duration, this particular light should be displayed. After that duration, this particular light should be displayed. After that duration, and that particular light should be displayed, right? Now this programming is given to your processor. Now according to that program, the processor will operate, right? Now if I want to display a red light for 2 minutes, right? Now I will write a program that it should be displayed for 2 minutes, right? And this programming is under your assembly language programming. Whatever the programming we are giving to the processor is your middle level language, nothing but assembly language programming, right? Now if I want to display a red light for that particular duration, that means for 2 minutes I want to display red light, right? Now you have to write a program for this duration to this duration, red light should be displayed. After that duration, green light should be displayed. Now after any particular duration, yellow light should be displayed, right? We have to write a program in a such a way that for that particular duration this light should be displayed, and for remaining duration another light should be displayed. Now this program is given to the processor under your traffic light system. Now according to that programming part, the processor will operate, right? Now according to this operation, the particular light will be displayed, right? Now this is, we are requiring programming under remote and also under traffic light. Now if you consider another mobile, under mobile also we are using processor. We have traffic light, remote, mobile, all these cases where we can use microprocessor, right? Now if you want to switch on the fan, right? Now can we use microprocessor here? No, right? If I switch on the fan will get on condition, right? Now if I switch off the fan will be under off condition, right? Here we don't require any programming, only two states, either on state or off state. Here we don't require any programming. If I switch on, the fan will get on. If I switch off, the fan will get off, right? Normal condition. Here we don't require any programming, right? Now here we don't use any microprocessor. Now that is the difference between where we can use microprocessor and where we can't use microprocessor, right? Now the microprocessor is used where we require programming. Examples are your traffic light system, we can use processor. Under your remote, mobile, all these uses microprocessor, which are used for your programming. You can use microprocessor where we can use programming, right? Now this is about the introduction, what is mean by the processor and where we can use processor, microprocessor, right? Now you can use any part of your real-time systems, you can use microprocessor, but where we require programming, right? Now this is about the introduction. Now as I have said, it is the central part of the computer system, right? Microprocessor is the central part of the computer system. Now if you consider your laptop, now which processor is present under it, right? As I have said, it is the central part of the computer system. Now if I consider laptop, the basic present version of the laptop, now the processor present in it was Intel i7 core i7 or i7 core, right? Now i5, i3, right? Now these are the processors that are present under your laptop, right? If you see your laptop, the present version of the laptop, now it contains the processor Intel core i7, right? The present version contain. Now this is the present processor that is under working state, right? Now the present existing processor was your Intel core i7. Before that you will have i5, before that you will have i3, right? Now this is the present microprocessor which is present under your laptop, that is Intel core i7, right? Now we won't learn this Intel core i7 processor. Under your subject we will see the basic version of the processor, basic version of the processor. Now the first, what are the, let us see. Now the first microprocessor invented by Intel was 8085, right? The first microprocessor invented by Intel was 8085. Now the next microprocessor came into picture was 8086. Now this was also invented by Intel, but later it is combined with IBM, right? Now before this 8085 you have 4004 processor, 8008 processor. Now those have some disadvantages, right? Before this you have two more processors came into picture. Now those have some disadvantages, that's why we won't consider that particular processor. Now the first microprocessor we will consider it as 8085. Before this, you have two more processor invented, which is of 4-bit, right, which will perform 4-bit arithmetic and logical operation. You have 4004 processor, right, but those we won't consider because it has some disadvantages. But in your syllabus we will see the first microprocessor, that is your 8085. We will see the architecture, and we will see the instruction set, and we will see the programming part under your 8085 micro basic version. If you understand this basic version, you can understand any processor. You can understand Intel Core i7 also. The basic part, if you are perfect in that, then you can understand any microprocessor, right? In your syllabus you have 8085 processor. Now that is first invented by Intel, and next invented processor was 8086, and that is invented by Intel. Later it is combined with IBM, right? Now after 8086, next invention was 80186 processor. Next invention was 80186 processor. Now after this 80186, the next processor came into picture was 80286, right? Now after 80286, the next processor invented was 80386. Now after 80386, 80486 is the processor that is invented. Now after 80486, 80586 is the processor that has invented, right? Now under 80586 we have different versions, that is Pentium 1, 2, Pentium 2, Pentium 3 and Pentium 4. Now these processors are used under your multimedia application. Pentium 1, Pentium 2, Pentium 3. These are the processors that are used under your multimedia application. You can use anywhere. Microprocessor can be used anywhere in your real time. Only the point you have to remember is we require programming, right? Microprocessor is used where we require programming, right? Now if you see the 80586 processor, now the available versions under this are Pentium 1, 2, 3 and 4, right? Now these are used under your multimedia application. Under multimedia application also we will use processor, right? Now those processors used are Pentium 1, 2, 3 or 4, right? Now after this 80586, next invented processor was Core 2 Duo, right? Now after Core 2 Duo, you have Core i7, i3, i5 and i7, right? Now this goes on. This invention of a processor will go on. For every 3 to 4 years you will get a new microprocessor into the market, right? For every 3 to 4 years, right? For every 3 to 4 years a new microprocessor you will get into the market, right? Now if you see 8085 and 8086, now these are invented in the year 1970s. Those are invented under 1970s. 8085 processor and 8086 processors are invented. After 8086, 80186, 286, 386, 486, 586. Now the present microprocessor under picture is Core i7, right? Now after 2 to 3 years also you will get another processor, right? You will get another processor for every 3 to 4 years. For every 3 to 4 years a new microprocessor is invented, and that will come into the market, right? Now this is about the introduction, right? Microprocessor is nothing but the central unit of the PC which performs arithmetic and logical operation, right? Now if you see your present version of the laptop, now the processor present in it was Intel Core i7, right? Now before that version you will have i5, i3, right? Now these are the present processors that are embedded in your laptop, that are present in your laptop, right? Now the first microprocessor invented was 8085, right, which is invented by Intel in the year 1970s, right? Now after that, before 8085 you have one more processor, that is 4004, which is a 4-bit processor, but that has some disadvantages. That's why we won't study that particular processor. We will study about 8085 processor, right? Now after 8085 processor, next invented processor was 8086. Now after that 80186, 286, 386, 486, 586, and the available versions of your 586 are Pentium 1, 2, 3 and 4. Now those are used under your multimedia applications, right? Now after 8056, Core 2 Duo is the processor came into the market. Now after that Core i3, i5, i7. Now the existing processor in the market is Core i7, right? Now which is present under your laptop, right? Now this is about the introduction. Now as I have said, processor is the central unit of a PC, right? As I have said, processor is the central unit of a PC. Now let us see where this processor is present in your computer system or the laptop, right? Where this microprocessor is present in your computer system or laptop. Now let us see where it fits, right? Exactly where we can see the processor under your PC, right? Now you know input devices and output devices. I/O devices, nothing but your input devices and output devices, right? Now you have to remember, from now onwards you have to remember these shortcuts, right? I/O, which is nothing but, you know already, this input or output devices, right? Now what are the input devices? You have keyboard, mouse. Now all these are nothing but your input device, right? Now what it will do, we will provide some input, right? We will provide some input through this device, right? Now what are output devices? You have printer and another one is monitor, right? Now monitor. Now all these are nothing but your output devices, right? Now we can display some output, right? We can display some output using printer or the monitor, right? Now in between input devices and output devices, now you are processing something, right? You are processing something, right? Now that decision making, see, now for example I am taking, now a equals to 3 and b equals to some 2 value and c equals to a plus b. Now consider this is the program, right? Now consider this is the program. Now I want to execute this program. Now what happens? Now these are the inputs which are given by the user through keyboard or the mouse, right? We are giving some inputs which by the keyboard or the mouse, right? Now this particular operation which will do, now this decision making is done by the CPU, central processing unit, right? Now this particular decision making input you are giving through keyboard and mouse, right? Now whatever the process that we want to do, that particular decision making is done by the central processing unit. Now the result is 5, right? Now this is displayed either through the printer or the monitor, right? Now CPU, the decision making happens inside the CPU. Whatever the decision making, whether it is a particular operation, what a user want to do, that particular operations decision making is done by the CPU, right? Now all decision making here in a PC system happens inside the CPU, right? Now CPU has motherboard, you know this already, right? Now CPU contains motherboard, right? Now in the motherboard, on the right side in the middle part, right in middle, right? On the right side in the middle part, you will observe processor. CPU has a motherboard, and on the motherboard of CPU, on the right side in the middle part, you will observe processor, right? This is the position where the microprocessor is present under your computer system, right? Directly you can't see microprocessor. Directly it is a small chip like device. It is microprocessor. It is a 40 pin device. It contains 40 pins, right? Now basically it is a 40 pin device. I am saying about 8085 or 8086, right? Now which is a 40 pin device. Now chip like system, right? Now you can't directly see the microprocessor on your motherboard of a CPU, right? Now this particular microprocessor is covered by the fan or heatsink. Right? If you remove the fan or the heatsink which is present on the motherboard of CPU, below that you will observe processor, which is a 40 pin IC. It is a IC 40 pin device, right? Now below that, if you remove fan or the heatsink which is present on the motherboard of CPU, below that you will observe the processor. Directly you can't see the processor. It is covered by the fan or the heatsink, right? Now this is the position where the processor is present under your computer system, right? Now CPU, all the decision input device we will give input, and output device will collect the, through input devices we will give the input, and through output devices will collect the output, right? Now all the decision making is done by the CPU, right? Central processing unit. Now CPU has a motherboard, right? Now on the motherboard, right in the middle, on the right side in the middle position, you will observe microprocessor, right? Directly you can't see the processor. That particular processor which is present in your computer system is covered by the heat sink or the fan, right? Is covered by the heat sink or the fan. If a computer uses 8085 processor, now that contains 40 pin IC. Basically it is a 40 pin device, 40 pin IC, right? 8085 and 8086 are 40 pin ICs, right? Now microprocessor, CPU has a motherboard on right in the middle you will observe processor which is covered by the heat or sink, right? Heat sink or fan, right? Now let me draw a simple diagram of computer system. Now what it contains? It contains microprocessor, MP. From now onwards you have to remember the shortcuts. MP stands for microprocessor, right? Now M/R, nothing but memory. M/R, nothing but memory. Now you know the shortcut. I/O, nothing but input devices, right? Now we will give input through input devices and you will collect output through output devices, right? Now this microprocessor, here you have connection and here you have connection, right? Now this is a basic computer system. Now let us see individually parts, right? Now you know about I/O, right? Now what I/O devices will do? Through input devices we will give input and through output devices we will collect output, right? Through input devices we will give input and through output devices we will collect output, right? Now that is about I/O devices, right? Now coming to memory, now what it will do? It will store some information, right? Stores information. Memory stores information, right? Now the memory stores information, right? Memory stores information, that is data file or program file, right? Data file or program file, right? Now the purpose of the memory is to store information, that is data file or the program file. Now what is mean by data file and what is mean by program file, right? Now under your computer you have Microsoft, right? MS Office, Microsoft Office, right? Now under that you have Word, PowerPoint, Excel, right? Now all these are present under your MS Office, right? Now if I consider MS Word, now that comes under your program file, right? Now whatever the data that we are giving to Word, MS Word, whatever the data that we are writing in the document, now that is nothing but data file. You have clear idea what is data file and what is program file, right? Now MS Word under your MS Office, right? Now MS Word will come into program file. Now what the user is providing the data, that comes under your data file. Now these two are stored under your memory. The purpose of the memory is to store the information, that is data file or the program file, right? Now we have different memories, right? Now we have different memories. Now it can't, now the different memories available are RAM memory, you know, RAM, ROM, and the different types of RAM or SRAM, static RAM, dynamic RAM, right? And you have flash memory. Now all these are the different memories through which you can store the information, that is data file or program file, right? Now directly we can't store data. Data file, now I want to store some data, right? Now that particular data is stored in the form of zeros and ones, right? See, now I'm giving some data. Now directly this particular data is not stored under your memory. This particular data is converted to zeros and ones, and this zeros and ones is stored in the memory, right? Now that it stores the data in the form of zeros and ones, right? Now it stores the data in the form of zeros and ones, right? Now see, if you see, this processor has a connection to I/O and processor has a connection to memory, right? Now here processor controls memory and the processor controls IO devices, right? Now the control over the memory and the IO devices is done by the processor, right? Now microprocessor will have a control over the memory and also control over the IO devices, right? Now what is the main job of the processor is to execute the program, right? The main job of the processor is to execute the program, right? Now what is mean by the program? Set of instructions, right? Program is nothing but set of instruction. I am drawing again here the diagram. Now here you have a MP, nothing but microprocessor, and here you have a memory. Now that stores the information in the form of zeros and ones, right? Zeros and ones is nothing but which language it is? Low level language, right? Machine level language or the low level language, right? Now the microprocessor controls memory and also controls IO devices, right? Now what is the main job of the processor is to execute the program, right? Now this has to execute program. The main job of the microprocessor is to execute program, right? Now what is mean by the program? Set of instructions, right? Now where the instructions are stored? See, I am going step by step, right? I am going step by step. Have a look into it. Now memory stores the information. Now the main job of the processor is to execute the program, right? Now program is nothing but set of instruction, right? Now where this set of instructions are stored? In the memory. You are storing the set of instructions in the memory, right? Set of instructions are stored in the memory, right? Now can we store directly the set of instructions? See, now let us assume A equals to 2, B equals to 3 and C equals to A plus B, right? Now assume this as the set of instructions, right? Now can we store directly to this into the memory? No, we can't store directly. And which language it is? High level language, user language or the high level language, right? Now this particular instructions can't be stored directly in the memory. First this has to get converted to low level language, nothing but zeros and ones, right? Now the high level language or the assembly language. For a processor we will use assembly language. For the programming, if you consider programming under your processor, we will use assembly language, right? Now the particular language you are giving under the programming part, that has to get converted to low level language, right? That has to get converted to low level language, right? Now high level language to low level language is converted by whom? Compiler, right? You heard this name, compiler, right? Compiler is used to convert high level language, which is nothing but the user language, into low level language, right? High level language into low level language. Low level language is nothing but zeros and ones, right? Stream of zeros and ones. Now this particular stream of zeros and ones is stored in the memory, right? Is stored in the memory, right? Now as this is one of the instruction under your microprocessor, add B comma C, right? Now the one of the instruction, meanwhile just remember, if you see that instruction you will have a clear idea. Add B comma C, what it will do, it will add the contents of B with contents of C, right? Now where you will store A, you will have a register. These are the register B, register C, register A. Later we will see that, right, while discussing about the instruction set. Now meanwhile remember, this is one of the instruction under your microprocessor. Now this instruction directly we can't store in the memory. First this has to get converted to low level language, that is zeros and ones, right? Now in order to convert high level language to low level language, we are using compiler, right? Now which language it is? Assembly language, right? Now assembly language should get converted to low level language. Now what we have to use? Assembler. Now assembler converts assembly language to low level language. These points you have to remember. Compiler converts high level language to low level language, whereas assembler converts medium level language or the assembly level language into low level language. Now this low level language is stored in the memory, that is stream of zeros and ones, right? Now this stream of zeros and ones we call it as opcode. This stream of zeros and ones we call it as opcode, which is nothing but binary form of instruction. This stream of zeros and ones we call it as opcode, which is nothing but binary form of instruction, right? Now this is how the memory and processor are related to each other. Now the processor, the main job is to execute the program, right? Now program is nothing but set of instructions. Now where this set of instructions are stored? Memory, right? Directly we can't store the set of instruction. Now first those has to get converted to low level language, and that low level language is nothing but stream of zeros and ones, that we call it as opcode. Now that opcodes or the low level language is stored in the memory, right? Now if the programming is of high level language, now that has to get converted to low level language using compiler, right? Now if the programming is assembly language, that has to get converted to low level language by the assembler, right? Now this is the about memory, right? How the instructions are stored in the memory, right? Under the memory you will store the set of instructions after converting into the low level language only, right? Now the main job of the processor is to execute the program, right? Now in order to execute the program, now it will follow three steps, that is fetch, decode and execute, right? Now these are the three steps that are followed by the processor in order to execute the program, right? In order to execute the program, it will follow three steps, right? Now first it will take instruction from the memory. First it will take instruction from the memory directly. Now again you may get doubt, instruction is nothing but which is converted into low level language, that is stream of zeros and ones, right? Now first it will take the low level language, that is first it will fetch the instruction, it will take the instruction from the memory which is converted into low level language, and that is stored in the memory, right? For which is nothing but fetch. Fetch is nothing but it will take the instruction which is in the form of low level language, right? It will take the instruction which is in the form of low level language from the memory. That is first part of the microprocessor in order to execute the program, right? Next it will decode that particular instruction, opcode, right? Opcode it will fetch, next it will decode it, and next it will execute it, right? Next it will decode it and next it will execute it, right? Now these are the three steps that are involved in the microprocessor in order to execute the program. First it will take the instruction which is in the low level language, right? Instruction which is in the low level language from the memory. That particular step we call it as fetch, right? Now after fetching the instruction, it will decode that. That means it will convert low level language to, right? It will decode that, right? Now it will whatever the low level language instruction is fetched from the memory, now it will decode that, and after that decoding it will execute that, right? Now let me explain with an example the operation of the processor, that is fetch, decode and execute, right? Now let us consider a basic microprocessor, right? Let us consider a basic microprocessor. Now consider basic microprocessor, right? Now assume it has only 4 instructions, right? I am considering a basic processor. Now I am taking an example to explain you the operation of a processor, that is fetching, decoding and executing, right? Now let us assume a basic processor and this has only 4 instructions, right? This particular microprocessor has just 4 instructions, that is addition, subtraction, multiplication and division, right? Since it has 4 instructions, now these 4 instructions, how many opcodes you will have? 4 opcodes, right? Now what is mean by the opcode? Binary form of information, right? Opcode is nothing but binary form of instruction, right? Now this particular instruction that is available in the binary form, that we call it as opcode, right? Now this add, after converting into low level language, you will have one value, and that is called one opcode, right? And subtraction, that has to get converted to low level language, one more opcode. For multiplication, that has to convert it to low level language, one more opcode. And division, one more opcode. Opcode is nothing but binary form of instruction, that is converting that particular instruction into low level language, right? Now consider basic microprocessor. Now it has 4 instructions, right? Now 4 instructions, since it is having 4 instructions, how many opcodes you will have? 4 opcodes, right? Now opcodes will be of how many bits? 2 bits, right? 2 power n equals to 4. Remember this scenario, right? Based on this only you will get the number of bits for the opcode, right? Now what is the value of n? N equals to 2, right? Now this indicates opcodes will be of how many bits? 2 bits. Opcodes will be of 2 bits, right? Now what are the different possibilities with your 2 bits? 0 0 0 1 1 0 1 1, right? Now these are the different possibilities with your 2 bits, right? Now let me take another example, right, to understand the opcodes and the number of bits. That means opcode is having how many number of bits, right? Now consider a processor. It has 8 instructions, right? Since it has 8 instructions, that instruction has to get converted to binary form, nothing but low level language, nothing but how many opcodes you will have? 8 instructions, 8 opcodes, right? Now the opcodes will be of how many bits? You have 8 instructions, 2 power n. Now what is the value of n? N equals to 3, right? Now the opcode will be of 3 bits, right? Now what are the different possibilities with your 3 bits? 0 0 0 0 0 1 0 1 0 0 1 1, like this, so on up to 1 right? Now that is how you have to identify, right? Now that can be extendable for your 4 instruction processor and 32 instruction processor, like that, so on, right? Now here we are assuming a basic processor which has only 4 instruction, that is addition, multiplication, subtraction and division. Since it is having 4 instruction, now 4 opcodes will have. Opcode is nothing but binary form of instruction. After converting instruction into low level language, that we call it as opcode. Opcode is nothing but binary form of instruction, right? Since we have 4 instructions, 4 opcodes. Now the opcode will be of how many bits based on this scenario? 2 bits, right? Based on this scenario, opcode will be of 2 bits, right? Now what are the different possibilities with 2 bits? 0 0 0 1 1 0 and 1 1, right? Now the 0 0 is the opcode assume for addition, and this is the opcode for subtraction, and this is the opcode for multiplication, and this is the opcode for division. This may vary, just I am assuming. Opcode for addition is 0 0, opcode for subtraction is 0 1, and for multiplication you have 1 0, and for division you have 1 1, right? Now this is which language? Assembly language, right? This is nothing but assembly language, and this is nothing but low level language, nothing but machine level language. Now the assembly language is getting converted to low level language by whom? Assembler, right? Assembly language is getting converted to low level language by the assembler. Now this is stored in memory. You are not storing this one directly, you are not storing the instructions, that is assembly language. This particular converted low level language is stored in the memory, right? Now again let me draw this. Now this stores the memory, right? Now this is the memory part, right? And this stores the low level language, that is 0 0 0 0 1 0 1 1, right? Now assume after converting the high level language, medium level language, nothing but assembly language, to the low level language. Now that converted low level language is stored in the memory, right? Now what here, to this side you have a processor, right? To this side you have a processor. Now what is the first step of a processor? It will take the instruction from the memory, and instruction is it will fetch the opcode, right? We can say it will fetch the opcode from the memory. Opcode is nothing but binary form of instruction, right? Now the first opcode in the memory is 0 0, right? First it is a fetching part. It will fetch the opcode. Opcode is nothing but binary form of instruction, right? Now the first it will fetch the instruction from the memory, right? Now here how many bits you have? 2 bits, right? Now in order to decode that, here you will use 2 by 4 decoder, right? 2 inputs, 4 outputs, right? 2 inputs, 4 outputs. Now inputs are this one and the outputs will be for addition, and for 0 1 you have subtraction, and for 1 0 you have multiplication, and for 1 1 you have division, right? First it will fetch the instruction from the memory. Now here this is given as input to the decoder, right? Now what decoder will do? It will decode, right? Now for 0 0 you are having which one? Addition, right? Now this is executed. Here you are decoding the opcode using the decoder, and here you are executing that, right? You know the operation of a decoder, right? You know the operation of the decoder. This is how the microprocessor is working. First it will fetch the instruction from the memory, and that is given to the decoder based on the input. Here you may contain 3-bit or 4-bit or 5-bit opcodes, right? Based on that you are giving that to the decoder, right? You are fetching the instruction, here you are decoding by the decoder, and here you are executing the program. Either it is addition or subtraction or multiplication or division, right? This is how the processor works, right? You have a 4 instructions, 4 opcodes, and the opcode will be of 2 bits, right? Now after converting assembly language to low level language, these are the possible opcodes, right? For the 2 bits the possible opcodes are 0 0 0 1 1 0 and 1 1, right? Now that you'll have a different opcode for different instruction, right? Now we are just assuming this particular opcode is for this one, this particular opcode is this. Now directly you can't store assembly language, you are storing this low level language in the memory, right? Now what the processor will do, it will first fetch the instruction. Now fetching the instruction is nothing but opcode, right? Opcode is nothing but binary form of instruction. Now that first it will take the opcode from the memory, next that is given to the decoder. Now the decoder will decode it, right? Whether it is addition or subtraction or multiplication or division based on the opcode, fetching opcode. Now there it will get executed, right? Here it is fetching, decoding, and here it is executed, right? Now this is how the basic processor works. Basic processor, just a simple processor we have considered. This is how the processor works: fetching the opcode, decoding that, after that executing, right? Now this is how the processor works, and this fetching, decoding and executing, these 3 steps together we call it as a instruction cycle. Fetching, decoding, because instruction cycle, right? Now all these 3 steps are done for a single instruction, right? For a single instruction, first we are taking it, decoding it, and then we are executing it, right? Now all these are done for a single instruction, that's why it is called instruction cycle, right? Instruction cycle includes 3 steps: fetching, decoding and executing, right? These 3 steps together we call it as a instruction cycle, right? And the last part about your processor, right? And the last, just we are describing basics of a processor. Here you have to perfect at your basics, then only you will understand the processor architecture or the operation of a processor, right? Now here the memory, it will store the information, right? It will store the information. Now as I have said, microprocessor will fetch the data, fetch the opcode, right? Now through how it will fetch, right? Using bus. You have a bus, this we call it as bus, and this is also bus, right? Microprocessor will take the data, any data, it may be any data, it will fetch the information either from the memory or the IO devices through the bus, right? It will fetch the data, any data, whatever it requires, that is taken from the IO devices or the memory through the bus, right? Bus is nothing but set of lines. Bus is nothing but set of lines, right? Bus is nothing but set of lines. Now here you have three types of buses. But here you have three types of buses. One is address bus, and another one is data bus, and another one is control bus. Now address bus will give the address, it will carry the address, right? Now address bus, it will carry address, right? The name itself indicates bus is nothing but transferring the information from one place to another place. Now bus is which is available in the form of set of lines, right? Now that particular bus, you have three types of buses under your processor. Now whatever the bus that is transferring the address, that we call it as address bus, and the data bus, it will carry data, and the control bus, it will carry the control signals, right? Now what are the control signals that we will see under the architecture of a processor, right? Now this includes read signal, RD indicates, and this is active low. Read bar indicates active low, and write signal, WR indicates write, and RD indicates this. We will you'll have a clear idea while discussing about the architecture, right? Now meanwhile, you just remember, now in order to transfer the information between two devices, to memory or the processor or IO devices, we will use the bus. Bus is used to transfer the information from one place to another place, right? Now here this bus is used to transfer the data from memory to microprocessor, and here this is also a bus because through which you are transferring the data from processor to IO devices, right? Now bus is used to transfer the information, and that bus is nothing but the set of lines, right? You have three different types of buses: address bus, data bus, and control bus, right? Now the address bus, through this address bus you will transfer the address of, and data bus, through which you will transfer, it will carry the data, and control bus, it will carry the control signals. Now what are control signals? We will see under the architecture of a processor, right? Now that includes RD, WR, control signals, reading the data, writing the data. This particular control signals are given to the processor, or it will take from the processor using the control bus, right? Meanwhile, remember, bus, what is meant by the bus? It will transfer the information. It is used to transfer the information which is available in the form of set of lines. We have three different types of buses: address bus, data bus, and control bus. Address bus will carry the address, data bus will carry the data, and control bus will carry the control signal. You know address, you know data. Data is nothing but input that we are giving, and control bus is nothing but the control signals, right? Now what are control signals? We will see. It includes read signal, write signal, hold signal, and hold acknowledgement signal. All these are your control signals. You will have a clear idea while seeing about the architecture of a processor, right? Meanwhile, you remember what is bus. Bus is used to transfer the data. Address bus, address. Data bus, data. Control bus, it will carry control signals. Now what are different types of control signals that we will see while seeing about the architecture of a processor, right? In the next lecture, we will see the architecture of a 8085 processor, right? Thank you.